Hello and welcome to the 1.07 screencast on dimensional analysis. I'm Mrs. Willie and let's get started. Our objectives for this screencast are to discuss how to express and manipulate chemical quantities using scientific conventions and mathematical procedures, including dimensional analysis, scientific notation, and significant figures. So everything we learned in lessons 1.05 and 1.06 now combined with the procedure of dimensional analysis. Dimensional analysis, also known as the factor label method, is used to convert from one unit to another. Perhaps the desired unit is more useful, or you need the desired unit for another calculation. So in our example here, we started with a measurement of 2.0 years, and we need to know how many seconds that is. So I start with my given, and I'm going to end with my unknown or wanted unit. I set up a series of conversions to get me from my known to my desired unit. So in our case, 365 days in 1 year, 24 hours in 1 day, 60 minutes in 1 hour, and 60 seconds in 1 minute. The purpose of this method is to cancel my units, which means I'm dividing so that I can cancel units and be left with the desired unit that I want. So in this case, the years cancel, I'm left with days. The days cancel, I'm left with hours. Hours cancel, I'm left with minutes. Minutes cancel, I'm left with seconds. Then I would multiply all values on the top to each other and divide them by all values multiplied on the bottom or in the denominator to give me 6.3 times 10 to the 7 seconds. I would report my answer to two significant figures because my original measured number was 2.0 with two significant figures. All conversion factors have an infinite number of sig figs. Therefore, we do not use them to report our values. Our final reported answer always comes off of the measured values that we are given. The conversion factor is just a ratio between two units of measurement. The factor is always set to 1, and then the unit to its equivalent on the second unit. Or it's reversed. So the 1 can be on the bottom in the denominator or on the top. So I could always flip this around. If I was going the other direction and started with seconds, then that would flip. The seconds would be on the bottom and the minutes would be on the top. The minutes would be on the bottom, the hours would be on the top. The hours would be on the bottom, the days would be on the top, the days would be on the bottom, the years would be on the top. So if I was going the opposite direction, I would flip my conversion factors and then the 1 would be on the top. My units always dictate which way I put my ratio. I always want to cancel my units and be left with my desired unit in the end, and I'm using division to cancel my units. So let's convert 555 square centimeters to square miles. My given or measured value is 555,000 centimeters squared. So that would be an exponent of a 2. And I'm trying to convert this to square miles. I determine my given, I determine my desired, and next I determine the conversion factors to get me there. So I know that in 1 centimeter, there is 0.39370 inches from my conversions table in 1.05. That's where I would find this information in my course packet. I know that in 1 foot, there's 12 inches, and I know in 1 mile, there's 5,280 feet. So I start with the 55,000 centimeters squared. I know that I have 1 centimeter is 0.39370 inches. I know that in 12 inches, there's 1 foot. So see, I flipped it. The 1 is on the top this time because I want the inches to cancel. I know that there are 5,280 feet in 1 mile. So the feet cancel and I'm left with the mile at the top. Because I started with square centimeters and I want to go to square miles, my conversion factors are not in squared units. I need to square my steps. I can do this by squaring or writing them out twice. So I could just put 55,000 times 0.39370 inches over 1 centimeter, and I would put it 2 times in my procedure. I could do 1 foot over 12 inches 2 times in my procedure. I could do 1 mile over 5,280 feet 2 times in my procedure. Or I could use the square. Know that this means that I square, because the square is on the outside of the parentheses, I square both the numerator and the denominator. So remember last time when I would type this into my calculator, I would take 555,000 times 0.39370 squared equals, and divide that by 12 squared times 5,280 squared, and I would come up with 2.14 times 10 to the minus 5th miles squared. I use 3 significant figures because my original answer has 3 significant figures in it. These are lagging zeros and no decimal point is present. So, a summary of your steps. Identify the given and wanted values. Write your own per expressions. Everybody has different pathways and they don't always have to be the same. They can still get you to the same place, just like we all have different ways from our house to school. Some days we take the highway, some days we take the side streets, but you determine which conversion factors you want to do. Share the units of the measurement of the given and wanted values, providing your pathway. Align the given quantities and the conversion factors so that the given units of measurement cancel and the wanted units of measurements are left in the numerator, always using the division in order to cancel my units. Write the work for your calculation, including all of the units for every conversion factor. Calculate the numerical answer. Cancel out units of measurement that disappear when divided by themselves. Rounding according to significant figure rules, the last unit standing is the unit of the answer. Include this unit after you round, and then check the answer to be sure both the number and the units make sense. Thank you for watching. See you next time.